Hi friends, this is Meera and welcome to my channel. Today we are going to discuss the basic concepts of center of gravity and centroid, their mathematical derivation and the basic difference between these two terms. So keep watching till the end. Consider a suspended wooden plate of thickness d. There are two types of forces acting on this plate. First, due to gravitational force, weight of elements of plate are acting vertically downward. And another one is the force in rope, which is acting in upward direction to hold the plate in position. Now, to satisfy the equilibrium condition, that is summation of all forces in horizontal and vertical directions to be equal to 0, resultant weight of plate must be on the line of string itself, say 1 1. Now, if we are changing the position of plate, resultant weight will act in direction of line of string again, say 2 2. We can get number of lines of action by changing the position of plate. But if you observe here, all lines are intersecting at one point and this particular point is called the center of gravity. To define precisely, center of gravity is a point through which the resultant of all gravity forces acts. If we put this plate on a pivot like this, it will freely rotate without falling on ground. This reminds me of action movies where our heroes lift villain overhead with one hand and throw away like that. I think they must have mastered the concept of center of gravity, right? In practical situation, especially when we are dealing with large and heavy bodies like a wall in a building, it is little difficult to suspend or rotate it. So let's see how center of gravity can be determined using mathematical equation. Let's say if we divide any area into small sections, the weight in each section is W1, W2 likewise, and coordinates of the same are x1, y1, x2, y2, etc. Total weight is W, which is acting at center of gravity at coordinates say x, y. Now take moment about x-axis. We get coordinates in y direction. Similarly, take moment about y-axis. We get x coordinates. Unlike center of gravity, centroid of an area is the point at which entire area of a plane is assumed to be concentrated. Suppose area of this plane is A with uniform thickness T and unit weight of material gamma. If we take moment about x-axis, we get this equation. Similarly, take moment about y-axis, we get x coordinates. In case of a single plane figure, if we divide the whole area into many small areas dA, then instead of summing up all individual areas, we can integrate it to calculate centroid using these equations. But it is difficult to calculate integrals, especially for composite structures. So, to ease the process, centroid of some basic shapes are provided in reference books. We can thus easily divide the area into more basic shapes, and as we already know the centroid of individual shapes, it becomes easy to find centroid of whole area with respect to reference axis. Here, as we can consider each shape as small element and as the number of divisions are less, centroid can be easily calculated using summation. Apart from equation, selection of reference axis is also important. Although the change in location of reference axis does not change centroid location, but its proper choice can simplify calculations. For example, for symmetrical shapes, if we place reference axis in middle, centroid location will be the center of reference axis. as there will be a similar element of area dA available in all opposite directions to nullify the effect. But for irregular shapes, it will be tedious to calculate all positive and negative values. So generally, leftmost and bottommost planes are considered as reference axes. As per definitions, concentration of weight of body is considered in case of center of gravity, while concentration of area of elements of body is considered in centroid. So, center of gravity applies to bodies with weight like cube, cone, cylinder, and centroid applies to plane areas like triangle, rectangle, or circle. For an object with homogeneous material and very small thickness, center of gravity and centroid are same. Now, if we change the material in some portion of object without changing the overall shape, centroid will remain same as area is not changed, but center of gravity will shift in direction of heavy material.